Live from Utrecht, this is Bitcoin
Explained.
Hey Sjors,
We're back.
we're back in beautiful sunny Utrecht. After I spent some time in Miami and Prague, and you spent some time in Prague and more Prague, is that right?
Mostly Prague.
You were in Prague for a while. That's where we recorded the previous episode, of course, about Stratum V2. And now we're back in Utrecht.
That's
and we're
right.
going to talk about Bitcoin Core 25, which is the latest Bitcoin Core release. But it came out a couple weeks ago. Because we were traveling, we didn't have time to record this episode yet. But, dear listener, we won't disappoint you. Here we are with our episode on Bitcoin Core 25.
Woohoo!
Before we get there,
It's
Well,
time for the critical part of the show.
I will be honest with you, Sjors. I am starting to regret doing the jingle myself. I do feel like I painted myself in the corner with this one.
Well, we can always...
But here we go. Sjors stacks sets. Sjors stacks sets. Sjors stacks sets.
Yay! Okay, I guess I'll read one. We have 250 sats from a unit of ACK, which I would probably read as Proost, as in cheers, because it's 2 beer glasses. And then there's another one from Michael Matulev, Short Stack Sats, without a music jingle. And MRMR 1750 sats.
How do you know that was
boosted.
without the music jingle, Sjors?
Because it doesn't have the music emoji. The last one did.
Oh, it actually did, and you still didn't sing it?
Yeah, this one doesn't.
Okay, well, what was the third one?
Whatever. Let's move on.
Sjors, do you still like this part of the episode? Because I don't think I've heard a single interesting message so far.
Well, we could make the criteria a bit stricter that the message should actually be interesting before we do the segment.
All right. Sjors stacked sets. Sjors Bitcoin Core 25 or 25.0.
Speaking of not very interesting,
Right. I was just going to say, this doesn't strike me as a particularly spectacular release. Maybe, as always, I guess at this point most listeners will know. But just for context, what does it mean that there is a new Bitcoin Core release?
it means about 6 months went by since the last Bitcoin Core release.
Right.
So it's basically whatever makes it in by, some date is what goes in. And then there's sometime, maybe a month or two spent on fixing bugs, not changing anything, just fixing bugs. And then it's released.
Right. So that's in contrast with some other types of software that will release a new version once they've included some kind of important new upgrade. Instead of that, Bitcoin Core just releases a new version every 6 months. So sometimes it's very interesting and sometimes not much happened in 6 months. That's really worth talking about, but we're still going to talk about it. Is that right?
It also depends on your interest, because if you look at the actual list of all the little commits that go in there, there's a lot of stuff that's under the hood. So if you find that stuff interesting, then there might actually be much more for you there.
Sure. I'm just approaching it from a podcast host perspective and what a average listener might find interesting. I think this is not going to be the most spectacular episode, but we're still going to do it, Sjors.
That's right.
Okay, so we highlighted a couple of upgrades that are at least kind of worth talking about, and we're just going to do them in order of us having written them down in our own show notes. They're not in order of importance or in order of anything else, right? I think.
That's right.
Okay, so number 1. There is some kind of performance improvement when it comes to huge transaction loads, and it has something to do with BRC20. Is that right?
Yeah, that's right. So in general, what we've seen in the last few months is the inscriptions, the ordinals, and then the BRC20 hypes, and also the stamps hype that we talked about in earlier episodes. It just causes...
Hang on. So yeah, we spoke about inscriptions, ordinals in a previous episode, as well as stamps. We have not spoken about BRC20.
No, BRC20 is based on inscriptions. They are inscriptions. They're just inscriptions with a piece of JSON in it. and they are supposed to be smart contracts. And I'm saying that with a very cynical face and scare quotes, because they are not smarts and they're also not contracts. But
so this is also what I thought. But you're sure about it? They are just using inscriptions, right?
Yeah.
And then they do. It's kind of
it's kind of like how
counterparty reinvented. Is that sort of that?
Yes.
Because that's how it sounds. It's just counterparty reinvented, more or less.
Yes.
Okay. Yep. Okay. And there's some kind of performance improvement in Bitcoin Core that has something to do with this.
Yeah. So I mean, generally speaking, what you see is people start using Bitcoin in very different ways. So the transactions look a little bit different than what you're used to. For example, in the last episode or a few episodes ago, we talked about how invalid blocks were produced because people were putting multiple signatures in. Now, that wasn't the problem with Bitcoin Core. That was just a problem with the miner software. But software just gets stressed out and starts hitting weird corners. And so similarly, these BRC20 transactions, they are atypically small. That's sort of one thing you would see about them. They're not the typical 2 input, 2 output transactions that you see normally. They're smaller.
Why? What do they look like, or what's the deal?
I think, and I haven't looked at them in detail, they're probably just 1 input, 1 output, a lot of them. Because a lot of time, what you do is you update the state of your smart contract. So you're saying, okay, my little fluffy image of a dolphin is now for sale. And that is just one JSON picture that you're uploading, or one piece of JSON that you're uploading to the blockchain. But you're not sending your coins anywhere. So you probably just send the same coin to yourself with this extra node on it.
Right. So we don't have to re-explain how inscriptions work, but you just put this data in the witness, and most nodes wouldn't even look at it, I guess.
Yeah.
And they're very small, like you said, because not much else is happening with the transaction.
Yeah. But
right. This is the idea. Okay, go on.
But it does mean they're a little smaller than expected. And then if you really look at how Bitcoin Core deals with things like the mempool, how transactions are relayed to other nodes before they go in a block, there were some assumptions in there that were assuming that was happening at about 7 transactions per second. And, with SegWit, that increased a bit. And for this type of usage, it should be slightly higher too. So basically, the new release contains some improvements to handle these higher numbers. But I'm being very vague here. So we should do another episode where we try to explain that in more detail.
I mean,
probably when I understand it.
Because it doesn't sound super interesting. But basically, what it comes down to, if I understand you correctly, is the Bitcoin Core software, the Bitcoin Core code is sort of calibrated with certain assumptions in it of how Bitcoin would usually be used. And then that software sort of knows, it's optimized for that situation. And now that situation kind of changed because of BRC20 and inscriptions and all of that. And this new Bitcoin Core release kind of takes this new way of using Bitcoin into account with its assumptions in its code.
Yeah, and I guess the bigger picture here is that, in blocks, we have a very hard limit. There's only so many megabytes that go into a block, so it's much easier to reason about sort of the worst case. But for the mempool, there are not really any rules. Because it's not really consensus, right? So it's a little bit more complicated to make code that handles all mempool scenarios ideally.
Right, okay. Now let's make this as practical as we can make this. So I'm a casual Bitcoin Core user. What's the benefit for me when I download Bitcoin Core 25? How does it help me?
Probably when there's another storm of these super small BRC20 transactions, your node will be happier. And by happier, I just mean it's probably going to make your computer less hot, use less memory,
require
stuff like that.
Less resources.
Yeah.
Okay, I like my computer cooler, so that's good. Next point. Right?
Yeah.
Okay, so there's some update with Miniscript. We've done a whole episode on Miniscript. Do you remember what episode that was?
I do not.
Look it up. And then I think in a previous Bitcoin Core release episode, we also mentioned that something Miniscript related was implemented, but it wasn't quite there, and it sounds like a new step has been made, right?
Yeah, so when we described Miniscript several years ago, I think it was one of the first episodes, where Miniscript is just a way, it's not a consensus change, it's not a soft fork, it's just a way to write scripts in a sane way, because writing scripts, Bitcoin script by hand is the best way to lose your money. And using Miniscript basically allows you to write scripts in a safe way. Now, Bitcoin Core added support for making a watch-only wallet. So that's a wallet that you can see your balance. You can create addresses, so you can use Miniscript and you can receive coins, but you couldn't spend it. So that's not ideal for most people. And so this new release does let you spend it. I'd still say it's pretty experimental. And there are some edge cases where you can actually not spend it.
Okay, so maybe as a very brief recap of Miniscript, actually. So the thing here is that the Bitcoin protocol allows certain kind of basic smart contract functionalities. So it allows multisig, it allows time locks, it allows, hash pre-images, it allows a bunch of things. And with Miniscript, it's actually very easy to implement these things in these smart contract ways. So you can receive coins in a certain way. So, for example, you can have a board of directors and a company, and they can say 3 out of 5 have to agree, or 2 out of 5 after a year, whatever. You can do that kind of stuff. Yep. And with Miniscript, you can implement that easily. Now with Bitcoin Core, okay, now is where I'm getting kind of lost. So, because this is what the Bitcoin protocol allows.
Yeah, so nothing changed in the Bitcoin protocol for Miniscript.
Right, so what is Bitcoin Core actually?
Well, Bitcoin Core is really multiple things. So Bitcoin Core is the node, the thing that checks the blocks for validity. Nothing changed there. But Bitcoin Core is also a software package that has a wallet built into it. Now, anybody's free to build a wallet. There's nothing special about the Bitcoin Core wallet. In fact, it's probably not one of the most user-friendly wallets, but it is quite powerful. At least it's becoming quite powerful. I think that's a better way to say it, thanks to Miniscript. So this wallet is able to use Miniscript.
But when you say use Miniscript.
It means you can give it a piece of Miniscript and it understands how to create addresses, how to sign transactions using it, etc.
Okay, but Miniscript is literally script. It's still something you code as a programmer, right?
Yeah.
So you give that code to the Bitcoin Core wallet. But okay, we're not talking about the GUI then. You have to go into the command line and you paste a piece of code there. And this is what Bitcoin Core will understand. Yeah,
but basically, I mean, some people may have been used to pasting xpubs around. So it's basically Miniscript. The way it works in practice is just an xpub with a bunch of extra script around it saying what to do with the xpub.
Okay, this is what you paste in the command line.
Yeah, you paste it in the command line, but there's no reason this could be added to the user interface too. It's just that you'll have to paste something magical that you probably don't understand. So that's a bit dangerous.
Okay. And so far, Bitcoin Core could understand it and you could receive the coins, but then they were just sitting there in your wallet and you couldn't actually spend them.
Yeah.
Yeah, sounds like being able to spend them is a pretty good upgrade.
It's one of the nicer features of Bitcoin, although it's good for inflation if people don't,
Okay, so I guess... Wait, but this is still sort of limited. It doesn't...
Yeah, I think for the most cases that you've described, it'll work. You can create a PSBT because there's now two hardware wallets or maybe 3. So the Ledger was first, and then I believe it was Coldcard or Bitbox, one of those two, added support for Miniscript, which means you can make like a multi-sig wallet with 3 physically different devices, with each having their own trade-offs. And in order to do that, you need PSBTs generally to move between these devices. But there are some limits to what you can do there. So there may be some obscure scripts that you can write them, you can receive coins on it, but you will not be able to send them to the hardware wallets using a PSBT. Some like edge case that if you know Miniscript, you'll probably understand the edge case. I don't.
And also, it doesn't work with Taproot yet.
Yeah, that's a bigger drawback, I would say. Miniscript was designed quite a while ago before Taproot. And it is initially designed for the use with SegWit, basically SegWit script. Actually, I think there's also a Miniscript standard for pre-SegWit script, but but at least it was designed for SegWit script. And so there has now been a recent modification to that proposal that also makes it work for Taproot script. Because most of the script is the same between SegWit and Taproot, most of the same opcodes, so you can make signatures, etc. But there's a few subtle changes in Taproot. So that changes a few things about Miniscript.
So is that would be an upgrade in the future potentially, I would assume.
Yeah, and that's one step at a time. So the first step would be that you can write Miniscript and then it'll generate, a script leaf in Taproot because you can put your individual scripts in individual leaves in the tree. But there's no way yet to decide how to most efficiently, distribute your scripts between all the leaves. So if you have like 5 different conditions, do you want to make 5 leaves in Taproot, or do you want to make 1 leaf that does 2 of them? That sort of stuff. There's nothing, no tooling for that yet.
Right. Okay. So we've
soon TM.
2 weeks. So we've mentioned 2 improvements so far, which one was the transaction loads, BRC20, and then we now mentioned Miniscript. And now we're getting to the third one, and that's actually the last one already.
Fast wallet rescan.
Fast wallet rescan. Sjors, explain.
So Bitcoin Core again has a wallet built into it. And let's say you first used that in 2012 and you received some Bitcoin. And then you were like, okay, let me put this wallet on a USB stick, put it in a vault somewhere physically. So the whole wallet, not just the backup code, just the actual file, and remove it from my computer because I'm traveling around with it. Now your node just keeps updating, keeps syncing. And then now you come back and you put the USB stick back into your computer. Maybe that's a bad idea if there's a lot of money on it, but let's say you do. And then your wallet is behind in a sense, because the new transactions that happened since 2012 would not be in that wallet file because it was in your vault, and your node doesn't know. It doesn't really track them either, not specifically. It just has all the blocks. So there's something called a rescan, which basically the wallet file.
Wait. Yeah. So no, because this is confusing, I think what you mean to say is you received coins on one wallet, and now after that you started using a new wallet, right? When you say syncing, your node is not syncing based on that wallet anymore.
Yeah, your node is still syncing. It's just storing all the blocks and checking the validity.
Yes.
But it's not keeping track of how that matters for your wallet.
Right. So you basically reinstalled Bitcoin Core or something like that. You got a new computer, something like that, right?
No, you can basically unload a wallet, and then load it again.
But
I guess another scenario would be yes. So you are you're reinstalling Bitcoin Core, and you're recovering your wallet, and you're trying to see if there's any coins in that wallet and find the transactions. And the only way to do that is to go through all the blocks and check for every block if there's something useful in that block. And that just takes a long time. Could be several hours.
Yo, what is going on, guys? We are proud to have Voltage as a sponsor of this episode. How many of you developers out there have wanted a streamlined infrastructure provider for your particular project? Well, I'll tell you what, Voltage is the Bitcoin infrastructure provider you have been looking for that makes building on Bitcoin quick and easy, whether it's Bitcoin nodes, Lightning nodes, BTC Pay, and so much more. But don't take it from me. Just ask the guys over at Amboss, Sphinx, Podcast Index, and Thunder Games, and so many others that you guys already know and love. Their enterprise-grade products make it fast and easy to build, deploy, and scale your next project. So make it easy on yourself. Even normie plebs can use the dashboard or API. Don't wait before the next block confirmation. Let your team focus on building great products and let Voltage handle all the rest. Voltage is your go-to zero management Bitcoin infrastructure solution.
That's not so bad.
Computer.
Okay,
It
go on.
depends on your patience.
I guess we can do better than that.
Yes, we can.
So how do we do better?
Yeah, so basically this is using the neutrino filters that we did an earlier episode about, the compact block filters. Forgot the episode. Look for Bitcoin Explained Neutrino and you'll find it. But the idea there is that light wallets can use these filters to figure out which blocks they need to download. So instead of downloading all the blocks, a mobile wallet can say, okay, it can figure out by itself, without revealing any private information to the outside world, which blocks it should download. And in order to do that, it needs to download something called these filters. These filters are much smaller than normal blocks. And so Bitcoin Core can create these filters, and now the wallet will take advantage of that, because rather than scanning every block from the history from the last time you checked your wallet, it now knows which blocks it needs to scan. And so it'll scan fewer blocks, which is faster.
Yes. So if I have a wallet.dat file on a USB stick, as we discussed, as in that's the example we're using, and I buy a new computer tomorrow and I sync Bitcoin Core, and now I get the wallet.dat file, somehow Bitcoin Core would know which blocks to download based on the wallet.
So the wallet.dat file contains the addresses that belong to your wallet. And so, well, depending on how old it is, that's going to be somewhere between 2,000 and 8,000, because it basically creates a cache of addresses. It knows these addresses, and yeah, using these filters, which Bitcoin Core will also have created, it's able to know which blocks are relevant and which blocks are not, because these filters are like a compressed summary of the blocks. So then it looks at the filters and it says, okay, do my addresses, if I run my addresses through this filter, does it say yes or no? And if it says yes, I'm going to download the block and I'm going to check everything. Filters are not accurate, so it's possible that you might download 10 times more blocks than you really need, but you're not downloading them all. And in the case of Bitcoin Core, it's not even about downloading them, it's just about checking them.
Well, yes. Well, so it doesn't work with a pruned node, right? You do need to have all the blocks available.
Correct. At the moment, it does not work with a pruned node, but if you had these filters on your computer, but pruned the blocks, you would be able to know which blocks to download again.
Right.
Which currently you can only do with some manual magic. So it is possible actually with the pruned node, but then you need a script. And basically, I've tried this myself, like just to experiment with it. You can, you can scan. I don't know if I tried this myself. I may not. No, I think I'm lying here. But it's in theory, it's possible to download all the blocks that you're missing and then scan it. But the wallet will be very confused.
Okay, well, I don't understand how this works, but that's probably because I forgot how Neutrino works. So if I want to understand that, I would have to go back to our own episode and listen to that.
Sounds good.
Unless, Sjors, you want to try explaining this right now?
You forgot how Neutrino works.
I mean, I don't remember.
I just told you. So the idea is
I understand the idea. I just don't understand why that...
why it works.
I don't understand.
It's magical math.
Yes, exactly.
Yeah.
Well, I feel that at some point I kind of understood it more than just magical math, but I'm not right now.
No, but the magical math basically says that you've done some calculations before to make a filter from a block, and then you can check against the filter. You say, do these addresses belong to this block or not? That is
okay.
And that is
do you want to just leave it there?
Yeah, because that's about as well as I can explain it.
Okay, we'll leave it there. If you want to know more, I think we go a little bit more in depth in our actual Neutrino episode.
Yeah, we missed the topic.
Well, I wasn't done, Sjors.
Oh.
I think you're going to bring up the RBF, the full RBF.
No.
Wait,
the 65 byte transactions.
Oh, you're right. Oh, you missed the topic. Sjors,
that's a big one.
You're so sharp today. Luckily, because I'm apparently not. Okay, so yes, there's something going on with the minimum size of transactions.
Yeah, we added more freedom to the mempool.
Is that so?
Yes. So
okay, explain.
So remember, there is consensus, which is what the rules for the blocks, and there's standardness, which is rules for the mempool.
Mm-hmm.
And generally, the standardness rules are stricter than the consensus rules. In fact, that's always the case. In other words, there are some transactions that are perfectly fine in a block, but they are not fine in the mempool. And this has to do with basically preventing DOS, denial of service attacks on your node. In this case, though, it's not really that. There is a minimum size, I believe it was 84 bytes. So any transaction that's less than 84 bytes would not be relayed by nodes. If it's in a block, it's fine.
Oh, is there a minimum size to be in blocks at all?
I don't think so.
Okay, so a transaction...
I mean, there's probably a minimum practical size because you have to point to a previous transaction, etc. So you have to...
Yeah, there's an actual minimum size that a transaction can be, but there's no consensus rule for it.
Yeah, I guess you'd say there's an inherent minimum size. Like it follows from what has to be in a transaction, but other than that, I don't think there's a number.
Okay, no. But there is a minimum size for the mempool policy.
Yeah, and I think it was something like 82 or 84, some number.
Yeah.
And this number has been decreased. Now it's 65.
Okay, why?
Well, so why? I mean, there's some use for it. So I think the idea is it makes it a little bit easier to burn coins if you need to.
Burn coins?
Yeah, if you have some dust that you want to get rid of, you want to remove it from the UTXO set.
Okay.
I think it's easier to do that with smaller transactions. But the...
Wait, what? Why would you want to do that?
Because you want to clean up the UTXO set.
Would you literally just want to throw away coins?
Well, you throw away coins that are not economical. Right? So
why not just leave it alone?
Because then it's sitting in people's memory and using up resources. Be a good citizen. Clean up your UTXOs.
I guess. Okay, yeah. Go on.
There may also be things. I mean, I think this was proposed by InstaGips, Greg Sanders, and he's working on ephemeral anchors, which are like ways to combine two transactions that are paying a zero fee, and then one is bumping the other. So maybe those transactions are actually smaller than, and maybe that's why he needs it. I haven't looked at the reasoning.
Mm-hmm.
In any case, it's possible, so it's done. The original reason is kind of funny. The original limit was made this weird number, like 82 or 84, because if they had made it 65, then the bad people would have understood why it was done, and they might have been able to exploit something before the fix was released. So this is a case of you have a vulnerability, you know that if people make 64-byte transactions, they can cause problems. You don't want to give that away too obviously, so you say, we're not going to make the limit 65, we're going to make it like 84, and then make up some excuse why 84 is a good number. Because nobody needed it.
This is super confusing. Luckily, I know what you're talking about.
All right. Well, maybe you can explain it.
Yes. So you mentioned the original number, and you said that was 82. So that's the confusing part. No. The original number was 64. That was a minimum of 64.
Yeah.
And then it was increased.
No, the original, there was no minimum. But it had to be increased above 64.
Oh, so it was not 64?
No, I think it was just...
So there was no minimum.
Yeah.
Okay. So there was no minimum. And then a minimum was imposed. When was this?
I think it was 2017, maybe
a
earlier.
while ago.
Yeah.
Then a minimum...
Might have been done even earlier.
Okay.
Yeah.
Then a minimum was imposed, and that minimum was 84?
Something like that.
Okay. And now that has been decreased to 65.
Exactly.
And what you're saying is the reason that 84 was picked originally is because they didn't... Like, originally 65 would have been ideal, but they didn't want to do that because it would reveal something.
Yeah.
So then they picked 84, which was a little bit more off to the side, and then hopefully attackers wouldn't notice it.
That's right.
Right? Okay, so what was wrong with... So why is 64 a magical number?
Yeah, and in fact, the strict rule that you really need is not 64. So it could be smaller than 64, it can be bigger than 64, but you don't want 64.
Okay.
And the reason has to do with Merkle trees. And we've talked about Merkle trees in earlier episodes. We've even tried to explain Merkle trees in earlier episodes. Mm-hmm. I think we should not try that again.
Probably multiple times.
Yeah. But the idea of a Merkle tree is like...
To no avail.
What it looks like, right. What it looks like is you take two transactions side by side, and then you hash... So you take... two transactions, you hash each of them, and then you put the hash of the first transaction on the left, the hash of the second transaction on the right. And the hash of a transaction is how many bytes?
64.
No.
Oh.
The hash of a transaction is...
I don't know.
Well, it's called SHA...
Should I know?
Yes, it's called SHA-256. The 256 stands for the number of bits. 256 divided by 8 is 32.
Okay.
So the hash is 32 bytes. You put two of them next to each other. That is 64.
Right.
And then this tree goes up and up and up. You keep combining two. So
what? This is not how a Merkle tree works. What?
That's exactly how a Merkle tree works. At least how it works in Bitcoin. So you're putting... Yeah, you start with transactions at the bottom. You pair them. Yeah. And then you basically hash each of them. Yeah. And you put the hashes next to each other. So 32 bytes next to 32 bytes. And that's 64 bytes in total.
Right, and you have these together, right?
Yeah, exactly.
Okay, yeah.
So you hash each of this, and so the problem there is that if you implemented this well, a Merkle tree, then it would be very clear how many leaves there would be. So you would basically say this is a Merkle tree and has so many leaves, and then somebody who looks at the Merkle tree can extract it and see these are all transaction hashes. Problem is in Bitcoin, it's done unsafely, and this has caused problems in the past. But basically, anything that's 64 bytes can be either a transaction of 64 bytes, or it can be one of these points inside the Merkle tree.
Yeah, okay, they look the same. I just want to clarify.
They look the same, and that is where multiple attacks have come from, including much older ones where you could create blocks that were like you would pretend that the block is invalid, and then you'd send the same thing again, all sorts of nasty things.
I just want to clarify. We're getting really into the weeds with weird, niche, but kind of interesting attacks here. So yeah, okay, the transaction hash is 32 bytes. I'm not gonna try to re-explain this one even.
Exactly.
But I was kind of
Transaction
following
height
you.
is 32 bytes. You put two of them next to each other, and now you have 64 bytes.
Yes.
So what does that mean? Well, I think it's
Sergio, yeah, Damien Lerner, yeah.
who wrote a blog post in 2017 explaining exactly what you can do to attack a user of an SPV wallet.
I'll add the link to the article in the show notes.
Yeah, you definitely want to read it. I'll try to explain it at some high level, but I find it confusing.
Yeah, go for it.
What is important to know is that this attack, so it's an attack on SPV wallets. So these are wallets that do not download full blocks, but only get a summary. And they get something called an SPV proof, which is saying, hey, this transaction exists. It's inside a block. It's here. It's inside this block. And then you give it all the block headers. So the SPV wallet knows, okay, there's some proof of work on top of this transaction. I can't check all the consensus rules, but at least I know some miner paid a lot of money to make this thing. So that's a kind of wallet user that's not very common anymore, because there's all sorts of problems with it, including the one we're about to describe. And then if you have a few $1 million in budget, you can perform this attack. And this was in 2017. I think you also need to have a pretty substantial amount of Bitcoin to do that, which was cheaper back then. What you do is you start creating transactions. You basically create a 64-byte transaction, and you pretend that it is part of this Merkle tree, or the other way around. See, this is where I even get confused. But the idea here is, because a transaction is hashed into 32 bytes, and there's two of them next to each other, that means that you can basically start making a how do you say this? There's certain parts of the transactions that can be whatever you want. And so you don't have to actually find a SHA-256 preimage. You have to find you have to try far fewer random transactions to be able to craft a transaction that looks like this. And one of the tricks he does is, like, he's saying, okay, I don't care about the amount in advance. So how many amounts can there be? There's just several bytes worth of what the amounts can be. So you basically keep looking for transactions with random different amounts. And then once you find the right hash, you use it, and then you send money to yourself. And anyway, you should read the blog post. The attack is quite expensive.
Yeah, can I summarize this? Here's the summary. SPV wallets are not secure if you want to accept millions of dollars worth of Bitcoin.
Yeah, assuming his calculation is correct, it would cost, at the time, several million to do this attack. And so if you are receiving more than a few million, you should absolutely run a full node.
Yeah, there are just some weird quirks in the Bitcoin protocol and minor incentives, and SPV is not secure for that.
No, and this attack also requires collaboration from a miner. So if you have collaboration from the miner anyway, you might as well just do a noble double spend.
Right.
But I think the target audience for this attack was automated systems that use SPV proofs. And I think at the time, Liquid had some components that, and RSK had some components that were fully automated and would use these SPV proofs and would have lots of money in them.
Okay, and now I want to ask you, so Bitcoin Core made this change? Or apparently they made the change a couple of years ago, actually. And now it's only now, I guess the developers figured most people have now upgraded. So now we can stop pretending that 84 was...
No, the pretending stopped earlier. So I think it was changed in 2017 without any explanation, although this blog post from him was around the same time. And then in 2019, there were comments added to the source code saying, actually, this is nonsense, but this is the reason.
Mm-hmm.
And then only now somebody bothered to actually change the limit, which is because nobody needed it.
Yeah.
And the other irony is...
So why is it needed now?
Well, I don't know. I mean, that's what we speculated on earlier. Maybe it's easier to burn money, or maybe it has something to do with these ephemeral anchors. I didn't study it in enough detail.
Okay. Anyway, so now the limit is 65. However, even now, that's only a policy change.
Yeah, so the irony is this never prevented the attack, because the attack, as described, actually requires being a miner or at least working with a miner. So it's kind of ironic, because a miner doesn't care about the standardness rules. So it was a step. It's like, okay, but there's something called defense in depth, where you say, okay, we think only a miner can do this, but maybe somebody else figures out a way to do it without the help of a miner. So it still helps to make it more difficult to relay these things. And there is a software proposal, which is called the Great Consensus Cleanup, which Matt Carollo proposed in 2017.
We may have done an episode on that, or no?
Yep, and one of the parts of that proposal was to make the minimum transaction size 65 bytes, and that would be consensus change.
Right.
Which is precisely for this reason.
Right. Okay, but that's not what this is. So that's one... I feel we're getting really into the weeds with this Bitcoin Core 25 episode, Sjors. I think this is like a very niche upgrade, but it's an upgrade. So we've now covered 4 topics. We're done with this one, right?
I think we've covered 4 of them.
Good. Are we done with the episode?
I think so.
I mean, that was this other thing you wanted to mention. Maybe something about the full RBF release.
Yeah, so there's an alternative implementation which you can download at your own risk. Make sure to check all the signatures, etc.
This is Peter Todd's implementation?
Yeah, it's Peter Todd, I think, together with Antoine Riard. This is they're lobbying the full RBF thing, which we've done plenty of episodes about. It's essentially Bitcoin Core 25 plus the full RBF stuff. And the one thing that's, I think, interesting about it is that when you just turn on full RBF, you're able to replace transactions, right, without setting the RBF signal. But the problem is if you're sending it to your peers, none of those peers might relay it. And so what you want to do is you want to find other nodes out there in the network that also support this feature. And there's something called service flags in which nodes can communicate that they have this feature and deliberately connect to him. So this patch does that. But I should warn you that changing peer-to-peer code is always very scary. So if just 1 or 2 people are doing that, I don't know. It's up to you.
And anyways, this is not Bitcoin Core really. And we were talking about Bitcoin Core. So that's the episode then, Sjors.
That's
Bitcoin
right.
Core 25 is released. Where can people find it?
BitcoinCore.org.
There you go.
So thank you for listening to Bitcoin
Explained.
Thank you, Miami, for the last 3 years in this amazing city. The whole world shut down, but Miami welcomed us with open arms. We want to show Bitcoin to the whole world. We are taking the conference on the road to set the stage for Bitcoin in a new city. Nashville. Bitcoin 2024 is coming to Nashville in Tennessee, a city that is known as a music and freedom city. Bitcoin 2024 in Nashville from July 25th to 27th.